Okay, as usual, I solved this one and you solved this one. All right, so let me begin by asking you a question. What type of radioactivity is this? Natural radioactivity or artificial radioactivity? Now, it is artificial radioactivity. How do I know? To start with, we have this atom here. Can you see that the atomic number is small, 7? Now, atoms that undergo natural radioactivity, usually they have heavy nuclei, like radium is 88, I think so, and 226. Can you see the proton number? It's very heavy. Now, another atom, like uranium, is 92. The mass is 238, I think so. All right, so you notice that the proton number is usually greater than or equal to, let's say, 80, sometimes 79 and above. Is that okay? So these are the atoms that ordinarily undergo natural radioactivity. Okay, but atoms like this undergo artificial radioactivity. Now, another reason is that I can see one of the bombarding projectiles. We call them bullets or accelerators, all right, which are used for disintegrating the nuclei of elements. All right, we have them. We have proton, neutron, and alpha particle, basically. Did you remember the experiment that Ernest Rutherford did? Of course, he used this guy, alpha particle, to bombard the gold foil. Do you remember? All right, so these are called bombarding projectiles or bullets. Is that okay? All right, so since I can see it here and I can see that the nuclei of this atom, nitrogen, is not heavy, then I know it is artificial radioactivity. Okay? All right, now again, I need you to take note of this. All right, take note of this. Notice here that the parent atom is not the same as the daughter atom whenever alpha particle is used as a bullet. But here, you notice that the parent atom is the same as the daughter atom, just that the mass numbers are different, but the atomic numbers are the same. So anytime this guy is involved, the neutron, you get a radioisotope. Anytime you use the neutron as a bombarding projectile, you get a radioisotope. Is that okay? All right, so let's answer the question. If I put one here and I put one here, you notice that the number of protons in the right direction will be equal to the number of protons in the left direction. I've always said that, Abi. All right, so 8 plus 1 will give us 9. And then if we come here, 7 plus 2 will also give us 9. So the equation is balanced. What about up? Here we have 14 plus 4 will give us 18. And here, 17 plus 1 will give us 18. So the nuclear equation is balanced as well. So the correct option is A. Now, a proton is also represented like this. All right, you can use normal hydrogen to represent a proton because they have the same nature. All right, question number 2, or rather question number 8. The time it will take a certain radioactive material with a half-life of 50 days to reduce to this. Okay, now before we look at the two methods, basically there are two methods, all right? One is much simpler than the other. But I'd like to list out the parameters first before I use the first method. So we have N, or N sub naught. This stands for the original amount. Okay, and we have n or just nt, n sub t. That's the amount remaining at time t. Okay, small letter t. Okay, and capital letter T is the half-life, and this is the decay constant. Take note of these 5 parameters. Now this one, the original amount will be 1 if the question is in terms of fraction. All right? Of course, it will be 100% if the question is in terms of percentage. Take note of that. Now, sometimes you may be given the original amount, maybe in grams or in kilogram, whatever. Is that okay? All right. So this is the amount remaining, very important. For instance, here we have 1 over 32. So if the original amount is 1, the amount remaining is 1 over 32. And then we don't know the time, but we know that the half-life is 50 days. All right? Immediately you can get the decay constant. Once you are given half-life, you can get the decay constant. And if you are given decay constant, you can get the half-life. So decay constant is equal to 0.693. You have to memorize this over half-life. All right? And if you are given decay constant and you want to find half-life, half-life will be 0.693 over half-life. Do you remember? Okay, so in this case, half-life will be equal to, let's punch it. So half-life will be equal to, the decay constant rather. What am I doing? The decay constant will be 0.693 divided by half-life, which is 50, right? And this will give us what? Let's punch. Okay, so it will give us 0.013 1386 approximately. Okay, and the unit of decay constant is A, whatever the unit of half-life is. So in this case, it will be per day, like you have days, you put raised to power minus 1, that is per days. All right, so if the half-life is given in months, it will be per month. If it's given in years, it will be per year. Did you get that? All right, now again, you don't convert to SI units in the course of solving questions that have to do with radioactivity. Take note of that. It's very, very important. All right? Okay. Okay. Again, always take note of these equations. Okay? These and these are the same. And of course, this one is the relationship between the half-life and the decay constant. Is that okay? All right. So again, let's list out the parameters just to be sure that you've not lost your track. So the original number, the original amount is 1. Now, because they did not specify, or because the question is in terms of fraction, you call it 1. Sometimes you can just use an alphabet X or Y, all right? And the amount remaining is n sub t, and that is 1 over 32. And then this is the time it takes for the particular sample of the radioactive nuclei to go from the original amount to the amount remaining. So the T, we don't know. The half-life is 50 days, and the decay constant, we got it to be 0.693 over 50, which is 0.0. Sorry, let me check again. That's 1386. 1386. And we said the unit is per days. All right. Okay, so let's answer the question using the first method. Now, the first method, I'm going to use arrow method. This is how it works. Okay, so you start with the original amount, which is 1, and then you make your arrow. After the first half-life, this 1 will be halved, and that will be 1 over 2. After the second half-life, 1 over 2 divided by 2 will be 1 over 4. After the third, 1 over 4 divided by 2 will be 1 over 8. After the fourth, 1 over 8 divided by 2 will be 1 over 16. After the fifth one, 1 over 16 divided by 2 will be 1 over 32. Okay, you stop. So once you get to this amount, you stop, all right? So count how many half-lives we have. 1, okay, 1, 2, 3, 4, and 5. So we have 5 half-lives. Okay, and since I know that 1 half-life is 50 days, therefore 5 half-lives will be equal to 5 times 50, which will give us 250 days. So this is the correct option, that is D. All right. Okay, so if I don't want to use the arrow method, I can as well decide to use this formula. You can use this one, or you use this one. It's the same thing. All right. So n sub t over n naught is equal to, have your constant raised to the power minus lambda t. Okay. So let's plug in the values. Nt is 1 over 32. So 1 over 32 divided by 1. Of course, it will still be the same thing. And then we have minus lambda is 0.01386 times t. Put our t there. All right, the next step will be to take the ln, the natural log, call it ln, ln, ln of both sides. So we take the ln of 1 over 32, and then we take the ln of this. Okay, now natural log, ln is the same thing as log to base e. Okay, and you know that if we have log e to base e, this will be equal to 1. Do you remember? Okay, so making this guy to become 1, the whole of this will become 1. So you just bring down what you have up here. All right. So we now have minus 0.01386t. Did you get the point? Normally, if you have this minus anything up here, all right, take a look at this. Let me explain further. So whatever you have up here, the power will come to the back. That's one of the laws of indices. Do you remember? If we have log 2 raised to power 3 to base 2, okay, so this 3 up will come to the back, and then log 2 to base 2 will become 1. Do you remember? All right, so, and then if we punch ln 1 over 32 is going to give us, so pick up your calculator, you will see ln written on one of the buttons. Okay, so if you punch, you're going to get that ln 1 over 32 is equal to minus 3.466. Is that okay? Okay, so that t will be minus 3.466 divided by minus 0.01. Okay, and if you do it well, you're going to get 250.1 days, just like we got before. So option D again. So whether you use the first method or the second method, you're going to get the same thing. All right, so this one is for you. Pause the video and give it a try. All right, so before we use the first method, let's list out the parameters we have. N naught, the original amount, is 60 grams. So it decreased from 60 grams to 2 grams. So the original amount is 64. NT is 2 grams. And then T, small t, is 24 days. Is that okay? Do we know half-life? That's what we are asked to find. What is the half-life? Okay. Do we know the decay constant? Of course we don't. All right. Remember, if you know decay constant, automatically you can find the half-life, or if you know the half-life, you can get the decay constant. Okay, so let's use the first method, the arrow method. Remember, you start with the original amount, 64 grams. After the first half-life, it will be 32. After the second half-life, 32 divided by 2 will be 16. After the next one, it will be 8. After the next, it will be 4. And then finally, it will be 2 grams. So we have to stop at 2 grams. All right? So you count the number of half-lives you have. 1, 2, 3, 4, 5. Okay? So 5 half-lives. But we are told that the 5 half-lives, all right? Okay, so considering this is the time it took to go from 64 to 2 grams, or 2 grams rather. Okay, so the 5 half-lives will be equal to the 24 grams, so that 1 half-life will now become 24 divided by 5, which will give you 4.8 grams. 4.8 grams. Okay, so that's the answer, because we are asked to find the half-life, so we don't need to find the decay constant. Okay, all right. So if you want to use the formula method, the same thing. N naught, remember, NT over N naught. All right, so you just plug in the values. NT is 2 grams. That's the amount remaining. 2 grams over 64 is equal to E raised to power. Then we have the T is 24. So lambda times 24. What will you do next? You take the lane of both sides. Lane 2 over 64 is the same thing as 1 over 32. Okay, you take the lane of this one, 24 lambda. All right, remember this will cancel. Then you bring this down. Now, if you solve correctly, you should get the same thing, 4.8. All right.